Thank you all for coming. This is about implementing transparency and reproducibility in economics. My name is Lars Wilhuber. I wear a lot of hats. I speak for none of them. All of this is my opinion, except when it's expressed as new policy for the American Economic Association, I guess. The background to where we're coming from is the scholarly discourse. Think of it as publications, but ultimately publications are only part of a scholarly discourse that is in person in exchanges nowadays on Twitter, back in the 18th century by letter. The basic idea is that we exchange ideas. I'm going to be focusing here on publications, and publications early on contained more or less everything that was needed to support the arguments that were being made. When it relates to data, it contained tables of the data, and the math in general, if you think about the early 20th century, was relatively simple. As data became electronic and as math was transcribed to code, some of the elements of these publications started to disappear from the publication record because in part they were difficult to access, difficult to store, difficult to preserve. If you think of the 60s and 70s when computer code was implemented on cards in a definitely transitory way, then it was very hard to cite it. It was very hard to provide it to somebody else. This is my favorite picture taken of the very first issue of the American Economic Review in 1911. The argument was about seasonal variations in the New York money market, and the data was provided as a big fold-out table. The publication format was adapted to accommodate that this was larger than any single page, but it needed to be provided to any reader of this in a way that allowed them to look at what was going on here. What we see today is often a poor proxy for this. And if you look at how this looks on JSTOR, you have to scroll through 3 scanned PDF pages that don't exactly replicate what's going on here. So to some extent, this hasn't gotten much better. There are, of course, nowadays many different ways of highlighting these attributes in publication, but the key part is that data tables like this, in whatever format they are, and in particular in machine-readable formats, have been one of the issues that the absence of their presentation has been detrimental to the idea of reproducibility. So my motivation here is that modern publications need to reacquire similar transparency and completeness as in the old, simpler days. And that's a lot what the discussion has been about. And we need to define first why that is important and what that actually is. So when I say replicability, what do we actually mean by it? Well, we actually mean what I call the replication continuum. And there's various definitions out there that have started to standardize some of the terms around this, because there have been many different terms that have been given over time. I will often use replicability. It just flows easier off the tongue than reproducibility, in particular when you start to conjugate it. But the definitions in this report and in others have sort of coalesced around the following. Reproducibility is, and often mentioned as computational reproducibility, is when you have the same data, the same code, the same methods, and the same context. Think of it as an audit study. What you see in front of you actually produces what's in the paper. That has been called other terms in particular in the economics literature, whether it be narrow replication, pure replication, verification, etc. And I will often use the term verification of computational reproducibility to describe what we are doing at the AEA. Replicability is when you take a step back from that. So replicability means we're going to start implementing something with different code, different aspects of the code, a different model, different software. You might also do a new data collection, an extended data collection, but basically still on the same population using fundamentally the same methods and in the same context. Much of this might occur within the same paper. These are the robustness tests that your referees have asked for that go into the appendix or that go into further a section on robustness tests. So they need not be something very different in a different publication. Generalizability, on the other hand, does go beyond any single paper. It's when folks start to apply this to a very different background when different data is being used, different methods are being used, different contexts or countries are being used. Okay. So that's sort of the overall framework, and there has been progress towards improving what I mentioned earlier, the clarity and availability of a common discourse about the subjects of articles. So for one, and we'll be talking a lot about this, replication archives and data availability policies have been around now for quite some time. The first of these started to emerge in the middle of the 1980s. They expanded substantially in the early 2000s. The oldest replication archive is at the Journal of Applied Econometrics. That goes back to 1985. But most of these journals have at some point coalesced around a relatively common standard of data availability policies. But part of that discourse is also shared open source software, whether those are Stata packages or R itself, are all features that appeared in the early 2000s. And they facilitate the discussion about what's going on because now you actually have a shared platform where you can see these analyses being conducted. Over the past 20 years, better public use and shared data has emerged, whether that's open or easily downloadable public data like at ICPSR or at IPAMS, or restricted access data. The research data networks of this world, the federal one, the Canadian one, even local ones in Quebec or in France or in Germany, are a product of the 2000s that have vastly expanded joint, common, very open access to data that underlies some confidentiality restrictions, but yet is accessible to hundreds of researchers. And better ways of accessing preprints is also a reaction to the absence of a larger discussion. The idea that you might share publications prior to their peer review and prior to their publication in the more formal literature, what's often called the gray literature, is a product of the early 2000s. Working papers in economics go back to the 70s, but both in economics and in physics, mathematics at arXiv, these expanded greatly in the early 2000s. So does that mean that we have no reproducibility issues? Well, the recent discussion about a replicability crisis clearly says no. On this continuum of just checking for reproducibility, the simply testing materials as provided by authors, the graph here shows statistics, just a heuristic, I don't want to go into many of the details, about various tests that have been done over the years. And they tend to gravitate around low 20s, 30%, right? The color dots at the end are from an experiment that we ran a couple of years ago of going through all the replication archives of one journal of the American Economic Association. And there is a definitional issue which leads to there being multiple dots there as to what is actually perfect reproducibility. Do you classify something as reproducible if it is partially reproducible? Do you use the access to the data as a criterion for selecting what you even attempt to do? And so these vary along these lines. The relatively high percentage that's shown there is that when data is available and we succeed in reproducing at least half of the tables and figures in the paper, we classified it as reproducible, and that is about 85%. The breakdown here is that there's a large fraction within economics that uses restricted access data. And so is 85% of when the data is available a half full or a half empty glass is a matter of discussion. Many in the open access community see that as detrimental. There's currently discussions under EPA to rules to consider whether data that cannot be openly shared is actually appropriately used for analysis and or policymaking. Failure to curate should have been obsoleted by the data availability policies, by authors providing the materials to the journals, but is still something that is of concern, especially when the data cannot be shared in a variety of ways. Poor citation practices make tracking down which data was actually used when it is not provided quite difficult at times. So these are actual quotes from papers and they're the full extent of how the data was actually sourced. And that may not always be enough. Right? But archives or data providers are also part of the problem because many don't provide permanent locations. And there are a few high-profile organizations participating in this call, as they are on every one of these presentations that I've given. And they are challenging at times for researchers to identify where they got the data from, because the data provider themselves do not necessarily provide very clear instructions on where the data might be 5 or 10 years from now. So what can we do? The first realization was, in many of the social sciences at least, that you need stronger enforcement of such data and actually code availability policies. So it's not sufficient to simply post such a policy to get some sort of zip package, throw it onto your website and be done. As it turns out, that doesn't work reliably. And so starting in particular with the American Journal of Political Science, but then expanding, including to the AEA, but also other econ journals, greater enforcement of these policies has been a recent innovation, if you want. So verifying the reproducibility is one key to improving the overall reproducibility. To do so prior to publication introduces additional complexity that I'll talk about in a bit. But current data availability policies were also broken. So for one, if the data act was not open access, so SAID was a restricted access data set, the basic approach was to grant an exemption. But exemption then meant that you also no longer provided systematic information as to where you got the data from. And that's very important. But on the other hand, should you even provide the data for such deposits if the data are already somewhere else? So you destroyed, by requesting that the data be deposited, you often destroyed some of the provenance information that came with it. And if data are at some, what we would consider to be very robust archive, should you even ask to have deposited? You should definitely describe where they are. And so some of the movement in the last couple of years has been about requiring greater transparency of the provenance of data and code, and figuring out ways to get authors to provide that information to display it in journals. You might ask, why were journals actually asking for these supplemental zip files and all these things? Well, I showed you for one that the obsolescence of various web pages leads to unavailability of these things over time. Journals can ensure longevity and persistence of these zip archives by taking custody of these objects and putting them onto their websites. They can ensure access. It's at our website, so we know that you can access it. Something's not going to go away, or there won't be any complicated things accessing, with the caveat, of course, that there might be paywalls. And they can ensure that the availability is there. But that's precisely what trusted repositories have as a business purpose. We call them data archives, call them trusted repositories. Their goal is to ensure such longevity, persistence, access, and availability. And with the advent of new self-deposit repositories, this has become easier over time. Now, self-deposit repositories are not a replacement for properly curated data at professional repositories. There's a difference between dropping something into a bucket and being sure that that bucket is going to stay around for the next 20, 30, 50 years, and actually creating data documentation and other things that relate to that. But this is a huge advancement. There are a number of sites out there. Dataverse, Figshare, OpenICP, Ara, Zenodo. Most of them are free. Some of them are with a commercial base. Some of them are nonprofit. So there's a huge diversity that allows researchers at various stages in their research lifecycle to deposit data and ensure at least the permanence and the accessibility of these. But what do we do about the restricted access data? Well, in fact, many of these same networks have grown into the equivalent of a data repository, of a data archive. There are a number of people from the FSRDC on this call, and clearly that network has acquired attributes that are more habitually associated with open archives elsewhere. The data is preserved, the data is made available, and there's a process for accessing. It just isn't a simple download. And so they have many of the same features of these of trusted repositories. And so the idea is to use trusted repositories wherever possible, but also, going back to the previous slide, to describe the provenance from these trusted repositories of the analysis results all the way into the paper. Now, there are problems with that. For one, I mentioned earlier the curation problem and the citation problem. When we start to expand to other allowable repositories, not all are created equal. To start with, the most obvious thing that I get to see a lot of times, GitHub, Dropbox, and the same, are not data or code repositories at all. At any point in time, somebody can delete their stuff from Dropbox. There's no permanence that is ensured in any way. And those are commercial companies that might go out of business, and who knows what they have in terms of a permanence or a transition policy. But it also applies to various institutions, whether you might be thinking of an institutional, a university repository in a zone, in a conflict zone, whether you're talking about at Cornell, where I think it might be reliable, but is it actually for the next 20 years, or at big institutions like Harvard? Are the National Archives a reliable repository? They rely on funding that is not necessarily assured for 50 years. Restricted access repositories are similar. If I can't take custody of the data has to stay someplace. How long will it stay there? And what are they doing to preserve it? If I'm using data from some bank, will they preserve it so that even if somebody else is allowed to access it 3 years, 10 years from now, will there still be data? How about school districts? How about research institutes affiliated with private institutions? How about the Census Bureau? So while many of these may actually be good repositories, the challenge for people using them is to figure out, are they actually repositories? So there is a need to describe them in various ways. Infrastructure to support that kind of description is evolving. And one of the key things is to cite them. Now, this is definitely not something that originated in economics. The idea of fair metadata and fair data is all about figuring out how to preserve these data in an open fashion. And it should be pointed out, the fair data principles apply primarily to metadata. So it's the metadata that has to be open. The data need not be, but it needs to be findable, accessible, interoperable, and reusable. Assessing that for various repositories around the world is a challenge. Data citation principles help with that, but data citations themselves are not enough. The data citation principles have enough information in them to be useful, but data citations as we see them in journals actually do not, because they tell you where the data might be if they are sufficiently precise, but they don't really tell you who can access for how long and under what conditions. In principle, these are covered by the data citation principles, but they're not covered by the style guides that we tend to use for these kinds of things, if even we do data citation. So emerging to support a better transparency of that have been data availability statements. I'll get back to what that implies at the American Economic Association in a bit. So data availability statements expand on data citations. They do not replace data citations. They allow authors to clarify where the data is, including various ways of accessing that. They should highlight reasons how the data can be made available or not, which increases transparency. They should, in principle, say something about how long the data would be available and about usage rights, right? We tend to think, for instance, that government data is in the public domain, but that's not always true elsewhere in the world, and that may not be obvious to other readers who are not familiar with what the US government rules on these things are. And that extends to all sorts of things. Just because you can download it from the internet does not actually mean that you have the rights to give it to somebody else. And so these usage rights are very important to convey. So all of that leads to the goal and the need to improve the provenance documentation of the data assets that go into our publications. So why should we actually care about that? For one, and this is a statement of desirability, not necessarily the most convincing argument for people who think that we are credible, but credibility is one of the key facets here. Think of statements about long-run impacts of an epidemic. And I'm not talking about the most recent one, I'm talking about the cholera. If you want to believe statements about the effects of epidemics on long-term outcomes, you're going to see graphics that sort of describe this, analysis that look at these kinds of things. You want to know where these come from, and that ultimately means that you need to look at where the data underlying it comes from. And those might be quite old, but you still need to find some of them, right? And you need to be sure that those are the relevant ones. That's what academic discussions actually imply. So once you have that idea there, you can now think of where is the data stored that was used for this analysis, and you can go in and download that data. Sorry. You can download that data, and you can download the code for that. And you can look at the code, and you can now assess as a scientist whether or not this analysis makes sense. You can rerun it, you can apply other things, you can replicate it, and you can possibly expand or generalize it. Right? And that's what data repositories associated with journals are doing. So the credibility of the claims in the paper relies on the transparency of every piece of the aspect there, all the way back to the source data, the methods to transform that, and then finally the analysis. Right? That credibility is key to understanding the statistics that we see around us, or that we see in the scientific literature. Right? Okay, so let me then switch to what we're doing at the American Economic Association. The American Economic Association has 8 journals, and the policies that I'm going to describe apply at this point to all 8 of them to varying degrees as they came into the process that we developed. So in a nutshell, we aspire to do 3 things. First, to preemptively improve code archives. Second, to create better archives, and in particular, to ensure that they have greater transparency and can be incorporated into the scientific architecture. And overall, better provenance tracking. Over time, that means to leave code where it is when that is appropriate, and to leave data where it is when that is appropriate. That is a challenge, and I'll get to some of those aspects. So the policy has been around for a while, but what we did is we changed some of that policy to re-emphasize some of these key aspects to it. Clearly and precisely documented wasn't always the case before we started enforcing this, and so we will look at that. Readily available are aspects both for data and for code that can be tested, and we test that. And it used to be that the emphasis was to provide prior to publication. That turns out sometimes to be a challenge to get authors, once a paper is accepted, to provide the materials on time. The policy asked for details sufficient to permit replication. That's an aspirational goal, and we set out to modify the policy so that we are actually going to start testing that. And we used to post things on the AA website. I just showed you an example of a recent publication where we have moved to a new infrastructure. So considering these things, last year in July, we expanded on this policy and clarified a few things. First of all, point is that the access to the data and the code is clearly and precisely documented. And we emphasize the fact that it has to be non-exclusive to the authors. Non-exclusive means there needs to be a reasonable way in which others can access the same code and the same data. We moved to requiring these materials prior to acceptance. And believe me, that ensures a very high degree of compliance, because unless those materials are provided, the paper doesn't actually get accepted. And we actually test some of the information about access to data, as well as whether it's sufficient. And we moved from the posting on the website to being archived in a repository where we collaborated with the Open ICPSR to have a journal-specific repository there. In and of itself, that's not an innovation. Others have done that way before the American Economic Association, but it's important for part of the creation of better archives. So let me describe a bit what we actually do for these 3 different components. Preemptively improving code archives means we actually conduct reproducibility checks. We run code as provided by the authors. We use the data as provided by the authors. We will download data as instructed by the authors. And when I say by the authors, it is in writing in the README that everybody else can see after it's published. So no private correspondence between us and the authors in general, other than to clarify the README afterwards. We are your guinea pig, essentially, as authors, because afterwards anybody else should be able to do exactly what we did, except we do it prior to publication. Now, 40% of data are not accessible. What can we do there? We work with groups that actually can conduct reproducibility checks for us when we cannot. And that doesn't need to be very complicated. We have sometimes obtained data from groups where the data is proprietary but not necessarily confidential, and so we have been able to run reproducibility checks there. We have worked with groups who have access to, say, the universe of tax files in the United States that we didn't have access to ourselves, and we asked them to run a reproducibility check on their colleagues but not co-authors. So we have worked successfully with a lot of groups. The complexity of data access sometimes means that we are going to ask others to run that for us. But we have been quite successful with that. What we do is that for every paper, we verify these various aspects. First of all, provenance documentation, we look for data citations. I'll show you what those might look like. It is a key aspect. It has been in principle in the AEA's guidelines for a decade, but very poorly enforced. So we enforce that now. We look at the quality of the README. Can we actually understand what's being said in the README? Is that just a one-liner run this thing with no information about where to get the data or what to do? Or is it a very explicit README? And we've seen everything from the 2-liners to the 50 pages. We look at the quality of the code. And I'm not saying that we are checking that the code is right. That is of a very different magnitude. We are checking to see, is it clear from the code where table 1 is being generated, where analysis data set 1 is being created, and why certain aspects are being done. Right? Is this intelligibly documented? And then if we have the data in the code and enough instructions in the README, we attempt to follow those instructions to reproduce the analysis in the paper. Finally, we look at the metadata in the repository that I'll show you in a moment. I should emphasize, we only do a reproducibility check. We do not do replication or generalization. That's for the literature to do. But we ensure that that first step, that at least this run of and these results in this paper have some empirical basis to them, and that the next persons can start from that basis to then start modifying the various other aspects on the replication continuum. All the guidance we provide, the READMEs that we expect to have, what should be in a README, the replication template that we use are posted publicly. So anybody who thinks of submitting an article and hopefully getting it accepted at the American Economic Association's journals can look at our various websites and find the guidelines for this. So there's no surprises. Who is doing this? Well, the checkers are not seasoned economists with tenure. They're undergraduates, not necessarily all from economics. But they can read a README, they can follow English language instructions, they know how to run Stata, they know how to run MATLAB, sometimes they know how to run all sorts of complicated Python or Julia things. Right? Over the past year, we've trained about 50 undergraduates to do this work with us. Meredith Welch is my graduate assistant who's also on this call right now, and there's a few others who have helped me in the past on this. We train undergraduates to do this, and they do a very good job of it. So if we can train undergraduates to verify the computational reproducibility, it should be relatively straightforward for PhD economists and tenured faculty and long-time employed economists to do the same thing. Goal is here to improve the ex-post reproducibility. Goal is that when something gets posted with our articles on their website, that we can be assured with a very high probability that it actually reproduces after the fact. There are still possibilities that we missed something or that it ran for us, but the documentation wasn't sufficient to replicate it 5 or 10 years from now. We don't know that yet. We do our best. Okay. Okay, and I mentioned that all of this information is publicly on the web. There are in the slide set at the end links to these various websites where these are. The replication template is also out there. It is a simple report that the students write with lots of instructions on what to do step by step. And it's not the same thing as a README because we're checking that a README has, but it very much aligns with that README. What have we done? These are statistics from end of November. So we're now April 1st. This has changed a lot. But in the first 4.5 months, as we were ramping up, we did 216 assessments for 138 papers. Okay. As of yesterday, we have approximately 600 assessments. And assessments are not the same thing as manuscripts. Manuscripts tend to go through multiple cycles. We have yet to see a manuscript that gets accepted on first pass, but sometimes turnaround can be quite quick on these. This is an order of magnitude larger than what most other journals are doing. And that is an issue that we can talk about in the discussion later on. Okay. We're still spending a lot of time doing this. It takes longer than we would like to. Sometimes that's because the computations actually take long. Sometimes it's simply because we have received too many for the kind of staff that we have. At present, we have 18 undergraduates working on it. We're in the process of training another 15. There is enough rotation with these students that these folks stay with me for a while, but also come summer, some of these will be going off to work with various research institutions for internships, etc. So we are constantly training new undergraduates to be our verifiers. And we work with various other agencies. 2 of these have helped me in the past, the 3rd one has not yet, so that we outsource some of the verifications as well. Okay, so what do I mean with better archives? So once we've checked this, the code and the data should be in an archive, well, that's where our AA data and code repository comes in. Where in the past, this was simply a zip file sitting on the web page. Now we have rich metadata that can be added to the deposits. We have a full viewable listing of all the data, of all the files that are within this deposit. You can download them individually, you can download the entire deposit, and you get citations of these as well. Of course, it's necessary to link it back, so we have both linkages back to the article and from the article to this, using the existing infrastructure of DOIs and the linkages that are behind it. Okay. There's also arcane metadata stuck within these pages, whether that's Dublin core or whether that's some JSON stuff. That is also important for the findability of these, because now you can actually find it through Google Scholar or Google Dataset Search or some other search engine that might be in use now or in the future. So this integrates the deposits into a very powerful way of accessing both the data and through the data back to the article. Okay. Some statistics from what we've done, about 72% of all data that, all articles that we use Stata, 22% use MATLAB, and there's a sprinkling of open source. So the bulk of what we see comes from Stata and MATLAB. Is that comparable to other sciences? No, it's not. There are very different software usages across the disciplines, and this is one testament of it, but it makes our life easier because we can focus on getting our undergrads trained on these 2 items. Are there differences in the reproducibility of that? The analysis for that is to follow. Okay. And finally, better provenance tracking. And this goes back to the data citations and often very intense working with the authors to improve this. So the data citation principles say that you actually want to put the proper credit and attribution to the provider of the data. And this is one of our sample citations that has been on the AA's website for the past decade. And yet most of the time, these are absent from the manuscripts. But we want this to be clearly and precisely documented. So we go through the manuscript, the article itself, the online appendix, the README, and verify, is the particular data object cited? Is there additional information on access? Does the URL actually lead to exact data? If you want to download the CPS from a US Census Bureau website, you can't just quote www.census.gov. That is insufficient to actually get to the data without additional research. If there is an application procedure, do we have enough information to find that application procedure? Are the other access procedures described? Are they complicated? Do they last long? Is there money involved? Is there time involved? Is there IRB involved? So all these things are important for a researcher to assess how complicated might it be to actually reproduce this particular article. And finally, I mentioned this earlier, is there license or data use information? Should the author provide the data? So we have had quite a few cases where the author says, I can't provide you with the data, and we check the information about the usage rights that the author acquired, and the answer might actually be yes. And then unless we find a reasonable repository for the data, the author actually has to provide the data. Conversely, we often check whether the author is allowed to provide the data. And again, we have checked some data use agreements and have told the authors, no, you actually cannot provide this data. Thank you for providing it to us for replication, but you're going to have to remove it from the archive. These are important aspects as we go through the overall provenance documentation. And authors struggle with this. We have saved authors from infringing on their data use agreements by second-guessing their ability to provide this. When an author says, oh, I think I've obfuscated the data enough, we will ask the question whether or not their data provider actually thinks they've obfuscated or anonymized or otherwise post-processed the data enough, right? But data publishers struggle with this as well. They make it very hard to find exact URLs. I'm going to call out the OECD here because I know that the OECD is actually working on changing this website to something that actually allows the user to do that. As you navigate the OECD statistics, the URL doesn't change. When it does change, it doesn't change again when you sort of dig down into their table. So it is quite hard to actually cite the precise table that you want somebody to do. You have to literally describe how you navigate this issue, right? Can you download the data or not? Lots of academic data publishers, research groups, etc., put data out there. And as it turns out, there's a copyright on it. And unless you ask for permission, that copyright says you cannot redistribute the data unless you invoke some sort of fair use, and good luck with that. But these folks are also open to discussions. So when we see something like that, and we see it for the second time, we go and ask folks whether or not that is actually their intent. And for this particular site, what you see is actually an archive, because after we asked, they changed their license very clearly to Creative Commons, which explicitly allows you to redistribute the data. And others say they're not going to do that, that they want authors to go back to their original website to download the data. Many websites now provide a suggested academic style citation. The St. Louis Fed does an excellent job with that, citing both the original provider of the data as well as where you got the data. So those two elements are key. That URL that they provide within that citation is 100% sufficient to recover the data at that point in time. And finally, restricted access data is also perfectly feasibly documented in such a way. The German RDC has done an excellent job of assigning DOIs to each one of their confidential restricted access data set and all versions thereof, listing them on a website. And that DOI leads to a page for each of these various versions that describes, among other things, the requirements for data access. So those are important aspects. Let me end the discussion here and open then the floor with some suggestions. First, for authors. The key to creating reproducible code and data archives is to follow some robust coding lines. Automate as much as possible. If we have seen code archives that had manual changes to various programs 37 times in order to generate various aspects of the robustness checks. That can be automated. We have seen authors write Fortran programs and recompile every time that they changed a parameter somewhere on line 750 of the code. Use methods to cycle through programs. Think of only slightly more sophisticated programming tools that each and every one of these programming languages has. And at the end, when you're done with your manuscript, before you submit it, run all that analysis code again. There are caveats to that. Suppose your analysis runs for 3 months. That is probably not doable. So keep meticulous logs. Ensure that all the aspects are done in a way that you can still figure out how you ran the first part of this by the time that you get to the last part. We recently had some very long discussions with authors who were using public use data, but were using a model that required 500,000 compute cycles on a supercomputer cluster. We were not going to rerun that, but we were discussing with them how much of the intermediate data they could provide us and other authors in order for at least parts of the analysis to be efficiently reproduced as part of the archive. We're still looking for the magic bullet for that one. We prefer master scripts, and authors should prefer master scripts. I already mentioned no manual manipulation, also no manual copying of results. If you're writing out results into one area needed for the next step, reference it in place. Write out tables and figures. Don't hand copy from various log files. Compute all numbers in a package, right? If you've got instructions about, oh, this elasticity, you can compute it like this, that's also something you can stick into code and then have the code say, this is what goes on page 5, right? Some of the more subtle things are that you might have been working on this paper for 5 years and you have all the packages necessary, but the next person out won't. What are the versions of those packages? So no manual install of packages to create a script, to create all the prerequisites, to install all necessary packages. We provide templates for that, for Stata, for R, for Python. It's embedded within the way that Python environments can be set up. Every single language has some way of doing that. And not unimportantly, when you use those packages, check if their package author, who's done an enormous amount of work that you're benefiting from, actually requires some citation. Again, we check that occasionally, and as it turns out, many of your favorite Stata packages actually want to be cited for the original paper that they were created in or wherever they are. So do that, because that's how those authors get credit. You're not paying them, you're giving them credit. And clear instructions. We don't need, replicators do not need a long prose description of the process of getting there. A linear checklist is really all that's needed. If that is not already done by the master script, that doesn't always work, but so have it clear instructions. Provide the data citations. Data citations are not hard. Provide data availability statements in the README or the appendix. What does it take to actually get at the data beyond simply knowing where the data comes from? And there are very many tricky data citations. How do you cite a data set that you extracted from the bank's credit card information database as of a particular date, right? These are citable just as much as other things were citable in the past. And we have a website where many of these examples are given and examples on how you can then cite the data. Okay. We are currently discussing among econ journals about incorporating data availability statements and incorporating a lot of the requested information into a standardized README that then could be used by authors. An example of that is on the website. For institutions, the key thing is that many of these things, many of these new features are just that. They are new to most researchers. And so training in these novel methods within various centers, institutions, etc., are important for current researchers, for future researchers. So universities have a role of integrating this into curricula, but it might just as well be that this is the summer intern boot camp that you get people to go through, right? Institutions need to provide better tools to streamline the process. DUIs for research data, deposit mechanisms that are integrated into how faculty work on campuses, how researchers work within their institutions. Facilitating citation by putting the obvious citation ways into the publication materials and the websites that provide access to the data. And just generally awareness. Training for replicators is not hard. There are a lot of instances out there. Katie and I are working on a training module at BITS. I am regularly training my own replicators for the particular job. Project Tier has been around and has some good guidance there as well. This is mainly focused on students, but all of these materials can be repurposed for staff training as well. And there may be scope to have formal internal verification services. Ask yourself as an institution, what is the reputational cost of irreproducible outputs? What's the time and money cost of verifying reproducibility? Done right, I can tell you it's actually not a lot. There's actually some benefit to doing that. And ultimately, what is the cost and benefit of transparency if you're publishing data, if you're advocating for things, if you're a policy group, etc. These mechanisms exist already at universities. So these are two university-based verification services that essentially provided as a service to the faculty prior to submission. Does everybody do that? Does every paper that goes out from these universities use these methods? Of course not. And how to scale this remains an open issue. When I mentioned earlier that we do this at the AEA, it doesn't come for free. And so one of the key concerns is how can you scale this to other journals, to the general mechanisms of doing so. Preemptively checking code archives conflicts with that restricted access data. So that tension between access and reproducibility will remain, and in particular, if one thinks of tiered access in the federal system in the United States, that will become an issue. There are pilots on doing this. So Cascade, which was one of the certification mechanisms that, verification mechanisms that we're using for public use data, also works with the French RDC system and offers a free service within the RDC to check code and reproducibility within the secure confines and with all the permissions in place. And finally, your students, your colleagues are possible verifiers. Your co-authors are possible verifiers of this. And as journals, we have a job to do as well. Any of the standards that I'm putting forward here are methods or tools. They need to be transportable across journals. There cannot be custom solutions. So figuring out what the common standard is, and believe me, many of the things that we see are not homogeneous. So we've put together what my Hungarian colleague has called a social science guild that collects many of this guidance into one place. It's expanding. And we want to put this information on the websites as well, so that this doesn't just get stuck in some README on an archive, but also possibly becomes obvious right on the landing page of a journal by highlighting the aspects that relate to how this data could be accessed or not. These slides are at this particular DOI. You can also find it on the Labor Dynamics GitHub, and that's where you'll find these additional resources as well. Thank you.